So that's why I will write 0.2f. So this will ensure that we only get 2 more digits after the decimal. So right after this, I will write A2. Now we will begin with our main module. I will write the handle. And I will assign new object to the handle. And then I will randomize this, let's say for 5 times. Else it will throw an error. So it will get repeated for 5 times. Now let's compile the code and let's check whether I have made any typos. Okay, there is an error. The line number 7. Okay, yeah, so this should be another curly brackets like this. So to declare a range using the inside method, you have to declare the range inside another sets of curly brackets. Let's run it again. Yeah, this time it's fine. So let's run the simulation. Let's run it. Okay, so we get uh, okay. Okay, so there's the issue. So even though we are getting the numbers in the real number format, but we are getting only 2 possible values. Those are 2 and 1, 2 and 1. And besides that, 1 is not even in the range between 1.28 and 2.90. So why is this happening? It is because here the expression is the context determined, because we are dividing the we are dividing the received value by 100, but by default, the default radix in system Verilog is decimal. So even though we are dividing it by 100 and we should receive a floating point number or a real number, but we are getting something like this because we are in fact getting the floating point number, but then it's getting changed to a decimal number, and the decimals, the two digits after decimals getting neglected, and after that only it is getting assigned to the variable a2. So what should we do to fix this? So the solution is quite simple. So let's try this. So instead of dividing this by 100, we will divide it by 100.0. So when you put 100.0, it is clearly visible that you are dividing the value received to A1 by a real number, a floating point number. So if you do that, we should get something in accurate decimal. So again, this will become self-determined, uh, sorry, context determined, and this A1, the whole value will get converted into a float before being assigned to A2. So let's find out whether this works or not. I've compiled the code for one more time, and let's run the simulation. As you can see, now we are getting the correct exact decimal values, the real values. And here you can see that uh, we are getting 2.45 as our first random real number, then 2.16, then 1.78, and 1.28, then 2.84. And all five of these are between 1.28 and 2.90. So that's the thing you need to remember, that first you will go ahead and write the constraint as per the requirement. Suppose this could have been more precise. This could have higher number of precision, like 1.287, 2.908. Then in that case, you could have just written something like this: 1287 and 2908. So after this, you just need to turn it back to the decimal, and to do that, you just have to divide it by 1000 in this case, and also you need to take care of the decimals for the floating point number. So that's why, remember, while dividing the random int received, you need to divide it with a real number. Otherwise, the default radix is integer, and with the definition of the context determined, you will get the value to int, which basically means all the things which are on the right side of the decimal will get neglected, and then it will get assigned to the real number a2. So you will get a real number uh, because you are using this percentage f, But the thing is that you will miss the accuracy and the decimal digits after the dot. So you just have to do that. So let's run the code for one more time for this particular value and let's find out. And also, yeah, this time I want three more digits after the decimal, so I will put it as 3f. So this time we are supposed to get the random numbers between 1.287 and 2.908. Okay, let's run the simulation. Oh, I forgot to change the string right here, but it's okay. We will see this. As you can see, just ignore these two numbers and focus on these two. So as you can see, we are getting values between 1.287 and 2.908. So the first number is 1.916, then 1.375, then 2.492, then 1.543, and the last number is 2.220. So using this simple steps, you could just generate any number between the given range in real number. Thank you so much.